Hello, and welcome to DEM for Blender. DEM is a fully procedural motion layer system that lets you build complex animations using editable motion layers instead of traditional keyframes. Rather than creating and managing hundreds of keyframes, DEM allows you to combine independent animation layers that remain fully editable throughout your entire workflow. Every change happens in real time. As you adjust parameters, modify timing, or combine multiple layers, your animation updates instantly, allowing you to experiment, iterate, and refine your work without interrupting your creative flow. Whether you're animating a single object, following a spline, controlling multiple objects, or adding procedural noise, DEM provides a fast, flexible, and completely non-destructive workflow. In this tutorial, we'll explore every feature of DEM Blender and build an animation from scratch, step by step. Okay, let's get started. In this scene, we have our controller model. As you can see, it doesn't have any animation yet. To get started, simply select the object and open the DEM panel. At the top, you'll find the different animation tabs. Each tab represents a different animation module, and they can all work together. For example, you can create a procedural animation using the animation module and later enhance it by adding procedural noise. We'll explore each module in detail later in this tutorial. The available modules are animation, spline, multi, and noise. The options below will also be covered later. For now, let's focus on how the layer system works. Here you'll find the buttons used to create new animation layers, and just below them, the dedicated DEM timeline. Let's open the timeline and create our first move layer. The animation range can be adjusted directly from the panel by setting the start and end frames. Or more intuitively, by editing the layer directly inside the timeline. Next, choose the movement axis. You can animate a single axis or combine multiple axes at the same time. You can also choose whether the movement is evaluated in global or local space. Finally, adjust the movement amount. Now press play. As you can see, the animation is generated entirely in real time and remains fully procedural. At the bottom, you'll find the Ease panel, where you can quickly change the motion style by choosing from several preset curves. If you need even more control, simply switch to Custom to open the curve editor and create your own easing profile. On the right side of the panel, you can duplicate the selected layer, delete it, or temporarily disable it. The same actions are also available directly from the timeline. You can enable or disable a layer using its checkbox, or simply press the delete key to remove the selected layer. For now, let's duplicate our move layer and shift its animation range directly inside the timeline. Notice how both layers blend together to create a single, continuous animation. Motion layers work additively, allowing you to build increasingly complex animations by simply stacking multiple layers. Now let's add a rotation layer. Set the animation range. Choose the rotation axis. Define the rotation angle, and finally select an easing curve. As you can see, every change is evaluated in real time. You can adjust parameters, experiment with different settings, and immediately see the result, without stopping the playback or interrupting your creative workflow. At any time, you can adjust the animation range of each layer directly from the timeline, change the movement axis, tweak the animation parameters, or simply add new layers to build more complex motion. Because every layer works procedurally and additively, you can experiment freely, refine your animation, and make changes in seconds without creating keyframes or destroying your previous work. To keep your project organized, you can rename your layers at any time, reorder them from the panel using the Move Up and Move Down buttons, or simply drag and drop them directly inside the timeline. Now let's add a scale layer. Just like before, set the animation range and define the scale amount. You can scale uniformly or control each axis independently, depending on the type of animation you want to create. The scale layer follows exactly the same workflow as the previous layers. You can move it along the timeline, adjust its timing, combine multiple scale layers additively, and modify any parameter in real time while the animation is playing. Once you understand how one layer works, you'll find the rest of DEM follows the same simple and consistent workflow. Now let's move on to the pivot layer. Create a new pivot layer and set its animation range. For now, let's temporarily disable the rotation layers to better understand how the pivot system works. As you adjust the pivot values and choose the movement axis, you'll notice that the visual pivot reference moves accordingly, giving you immediate feedback about the new rotation center. Now let's enable the rotation layers again. As you can see, the object now rotates around the animated pivot position in real time. Since the pivot itself can be animated procedurally, the center of rotation is no longer fixed, opening up a wide range of creative possibilities. Just like every other DEM layer, the pivot layer is fully editable at any time. You can adjust its timing, change its values, combine it with additional layers, and instantly preview the final result while the animation is playing. Although this tutorial focuses on explaining each feature individually, the real strength of DEM comes from combining multiple procedural layers together. By stacking different types of motion, you can quickly create anything from simple animations to complex motion systems, while keeping your workflow fast, flexible, and completely non-destructive. Let's take a look at the last layer available in the animation module, the visible layer. For now, let's temporarily disable the other layers so we can focus entirely on how this one works. Create a new visible layer. Its behavior is very simple, but extremely useful. All you need to do is specify the frame range where you want the object to be visible. For example, if we enter a range from frame 0 to frame 10, a visibility strip will appear in the timeline covering those frames. The object will only be visible during that interval. The Affect Children option should be enabled whenever the selected object contains child objects. In this example, our controller is organized as an empty containing all of its individual parts. By enabling Affect Children, the visibility is applied to the entire hierarchy, so the complete controller is only visible during the selected frame range. You can also define multiple visibility ranges by separating them with commas. Just like the other layers, these ranges can be edited directly from the timeline. Whenever you resize or move a visibility strip, the values in the panel are updated automatically, keeping both the panel and the timeline perfectly synchronized. Now let's take a look at the multi-module. For now, let's disable the animation layers so we can clearly see how multi works. Switch to the Multi tab. As you can see, our controller is organized as an empty containing all of its individual parts. To get started, simply click Refresh from Children. DEM will automatically load every child object into the list. The order of the objects directly affects how the animation is generated. Now let's create a new move layer and set its animation range. Choose the movement axis, and then adjust the amount value. The distribution parameter lets you choose how the animation is distributed across the objects. You can select either normal or explode. Let's switch to explode. As you can see, every part of the controller moves away following the order defined in the object list, creating a procedural explosion effect. To bring the model back together, simply duplicate the layer and reverse the amount value. In just a few seconds, we've created both the explosion and the reconstruction of the model without using a single keyframe. Just like in the animation module, you can stack multiple layers together. For example, let's add a rotation layer, adjust the rotation parameters, and now every individual part rotates procedurally while the controller explodes, creating a much richer and more dynamic animation. Now let's remove the rotation layer and see how different DM modules work together. Leave the multi-animation playing and switch back to the animation module. The animation we created earlier is still there. All we have to do is enable the layers again. As you can see, both procedural systems are evaluated simultaneously, automatically blending together into a single animation. Every layer remains completely independent, so you can adjust the timing, modify the parameters, enable or disable layers, or add new ones at any time, while the animation continues to play in real time. This modular workflow makes it incredibly easy to experiment with different ideas, combine multiple types of motion, and refine your animations without ever having to rebuild them from scratch. Now let's explore the spline module. In this scene, we have our controller and a spiral curve that we'll use as the animation path. Switch to the Spline tab. The first parameter is path. Simply select the spiral object, and DEM will use it as the motion path. Now create a new move layer. Set the animation range, and for now leave follow tangent disabled. Set the movement percentage to 100%. Press play. As you can see, the controller smoothly follows the entire spiral path. Now let's enable follow tangent. The controller automatically aligns itself with the direction of the curve as it moves along the path. If necessary, you can easily change the forward axis to match the orientation of your model. One of the strengths of the spline module is that it can be combined with additional procedural layers. For example, let's add a rotation layer. By adjusting its values, we can change the initial orientation of the controller without modifying the original object. We can also add additional rotation layers to make the controller spin while following the curve, creating much more dynamic motion. Now let's look at another powerful feature. Instead of using a single move layer, let's set the first one to 50% of the path. Duplicate the layer, move it later in the timeline, and change its target value to 100%. Even though we're using two separate procedural layers, DEM blends them together into a single continuous movement. This makes it easy to build complex spline animations by simply stacking and combining multiple motion layers. Let's look at another practical example. It's important to remember that every DEM module works with any animatable object in Blender, including meshes, cameras, lights, and much more. In this scene, we have a camera and a model placed at the center of a circle curve. Select the camera, then assign the circle as the path object. Now create a move layer and set the animation range and movement percentage. Press play. The camera now follows the circular path around the object. To make the shot more interesting, let's enable the Look At option and select the model at the center of the scene as the target. As you can see, the camera automatically keeps the model in frame while moving along the path, creating a smooth orbit animation with just a few clicks. Just like before, we can enhance the animation by adding a rotation layer. By adjusting the rotation values, we can introduce subtle camera motion or create more dynamic shots, while keeping the entire animation fully procedural and editable in real time. Now let's take a look at the last module, Noise. With this module, we can add procedural noise to any animation created with the other DEM modules. Let's create a Move Noise layer and set its parameters. Here we can control the intensity and the frequency of the effect. We can also add a Rotate Noise layer to create procedural rotational motion. The fade in and fade out parameters control how many frames the effect takes to reach its full intensity, starting from 0. You can think of them as a fade in and fade out for the noise effect. The noise module can be used as an additive effect on top of existing animations, or as a standalone procedural animation by itself. Now let me show you one of the most useful features in DEM. In this scene we have a model with a simple procedural animation. It contains a few layers in the animation module and a simple noise layer. We also have a completely different model that doesn't have any animation. Inside the animation module, you'll find the Copy DEM function. This allows you to copy the entire DEM animation, including all the modules, and paste it onto another object. As you can see, the animation is transferred immediately. However, since this model has a different orientation and scale, the result doesn't match perfectly. To solve this, simply adjust the object's position, rotation, and scale until you're happy with the result. Then click Capture Base Transform. DEM will record the current transform as the new starting point for the procedural animation. It's important to note that every copied layer remains fully editable. You can modify any parameter independently, creating multiple variations of the same animation on completely different objects without having to start from scratch. Another important feature of DEM is the ability to convert your procedural animation into a standard keyframe animation. Simply select the object, open the animation module, and click Bake DEM Animation. In just a few seconds, the entire procedural animation is converted into native Blender keyframes. This feature is particularly useful when you need to export your animation using FBX or other interchange formats, making it compatible with other 3D applications while preserving the final animation. This concludes the DEM Blender tutorial. As you've seen, DEM is much more than a collection of animation tools. It's a different way of thinking about animation. Instead of spending your time creating, adjusting, and managing hundreds of keyframes, you can focus on what really matters: designing motion. Every module has been built to work together, allowing you to combine procedural animation layers, experiment freely, and refine your ideas in real time, without destroying the work you've already done. This means less time rebuilding animations, less time making repetitive adjustments, and more time exploring new ideas and achieving the result you're looking for. Whether you're creating simple object animations or more advanced procedural setups, DEM gives you the flexibility to iterate quickly, make changes at any stage, and keep your entire workflow fully editable from start to finish. This tutorial has only shown the core features of DEM. The real potential comes from experimenting, combining modules, and discovering new workflows that fit your own projects. I hope DEM becomes a valuable part of your Blender workflow and helps you create better animations, faster, and with greater creative freedom. Thank you for watching, and enjoy using DEM for Blender.